Hi, welcome to part one, if you consider the introduction not being a part of my SQL class for Alteryx User, trying to get you up to speed with the basics that you need to know to be more effective at using, finding, storing your data by understanding what the RDBMS can do for you and how you can access it and communicate with it and receive information from it. So in today's data analytics world, you do have tools like Alteryx that reduce a lot of your dependencies on the RDBMS, but it does not remove them all. You'll reach points of frustration trying to figure out what you're doing, how you're doing it, things to do with testing, etc., where you actually need to get into that RDBMS and understand what it's doing. This class is not designed to give you all the information, but just to give you the surface so that you can begin to explore the RDMBS of your choice with a little bit of confidence and explore it further. So what we're going to talk about in this video is some basics of the RDBMS. Talk about how to connect to MySQL, which is the RDBMS that I'm using for my videos. I have it available up and running on an Amazon Web Services RDS server. Convenient way of getting it up and running and managing it. We'll also talk about how to name and reference the objects that are created. We'll look at the data catalog that is available within the RDBMS, and we'll talk about data types, how you're storing the actual fields that Alteryx will be processing. Primarily, I'll be showing examples of MySQL. I'll also make references to Teradata as well as to Oracle. I currently do not have access to either of those databases. I have used them in the past quite extensively, along with a number of others. So I am confident that the information that I'm sharing with you will enable you to cross-translate it pretty easily into the RDBMS that you are using. So when you connect to MySQL, or actually to any RDBMS, you always have a number of options for how to connect to the RDBMS in order to get your data. If you are using your RDBMS through Alteryx right now, then you have created a connection. Typically that is an ODBC connection, but we'll talk about three different connections very briefly: native connection, an ODBC connection, and just briefly mention JDBC, so that in case you're using a Java-based tool or actually writing in Java or a Java-based language, that is a second or a third methodology to connect to. When I talk about native connections, the easiest way to see that is if we go into a tool. So the tool to connect to a MySQL database is called MySQL Workbench. Teradata has SQL Assistant. Oracle has SQL Developer. There are also third-party tools that are available to you, some of which have native and also non-native connections. But a native connection is when the tool knows how to connect to your database all by itself, and all it's going to do is ask you for the parameters that it needs to know to connect. In this case, the tool is a MySQL tool, so it understands a MySQL database. I've already created my connection, but if you bring up the connection tool in order to manage it, you see that it's just asking you for the basic information that it needs to know to connect. Where you can find this information is by talking to either someone that is already connected to the database, a DBA for your organization, or someone in the operations or systems teams that also know how to connect to the database. Once I've created that connection, through this tool I simply click onto it, and it connects me into the database so I can begin work through the SQL language, and we'll postpone from further discussions about this tool until a few slides from now. If we talk about non-native connections, we can bring up Alteryx, and see that inside of Alteryx, when I go ahead and do my input data, I'll drag this into here. It'll ask me to connect to a file or a database. You notice that there is an Oracle, SQL Server, and a Hadoop option within these connection methods. These are native connections because the tool knows how to do the work to connect for you. So it'll simply prompt you for what it needs to know. I have found the best experience for connecting to Oracle is through this native connection here. But you still need to have the underlying connectivity information installed on your machine, such as any drivers necessary. Object of last resort is the other databases. Typically those would be your RDBMS connections. Now you can come to your RDBMS connections here, and what you will need to get to define it is your RDBMS admin tool. You also can just go to your start menu, search for RDBMS admin, and it will bring up the RDBMS admin tool here as well. So this is where you would define your connection to any other source that is not part of the native connectivity of the tool. In this case, you can see that I have created a connection using RDBMS to my RDS system. The nice thing about RDBMS is that once you create that connection, any tool that is RDBMS compliant will be able to use that one connection, so you don't have to recreate that connection over and over again for your machine. And we'll look a little bit more about what we do with MySQL from Alteryx here in a bit. Let's talk about naming objects. It's very critical that you name your objects properly and understand how your names will be represented in the database and how you must reference them, because that's all three different things. In case you don't know why naming is important, it's because you have a lot of different representations of names that you can use. I always recommend that as an organization that you agree at a naming standard and then you follow that naming standard so that everything looks consistent. But you have things such as uppercase, lowercase, camel case, Pascal case, as well as mixed case. When you're using SQL to create your database names, you pretty much can use any of these cases to create the name. The issue becomes that once you've created your objects, how does the RDBMS actually store that name? Some RDBMSs, such as MySQL, which we're using in my examples, as well as Teradata, will store the object name the same as you give it. So if you're using uppercase, lowercase, or Pascal case for your object, it will be stored the same as you typed it in. In Oracle, when you create your object, it will convert your name into uppercase. So if you created a really nice looking name using something like Pascal case, keep in mind that once it's in the database, it will be all uppercase and not quite as readable as you expected it to be. The latter side of this choice has to do with how do you reference that object once you've created it. So one thing to keep in mind that within MySQL, especially the version that I'm using right now, which is the version 8 Community Edition, so make sure you check what your version of MySQL requires. But in MySQL version 8 Community Edition, whatever the case structure of the name of the object that is created, that is also how I must reference it. So if I've created the object as all uppercase my object, I need to reference it as all uppercase my object. Teradata does not care what case you use within the name of an object, even though it stores it as that explicit case. You can reference it with any case that you choose. Oracle, while it also goes and uppercase is your name, you can reference that object using any case structure that you want, and Oracle knows how to translate it between the case that you type in and the uppercase that is its default. So you need to be careful how you name objects, how those objects' names are stored, and then how you reference them. One workaround that people like to use is this one in here, which is that you put your object name in double quotes. And typically what that means is that on the server, it will not translate at all what is inside of those double quotes. It also means that when you reference those objects, you must put it in uppercase. You must put it with quotes in the proper case as well in order for the RDBMS to find it. This is tricky when you're using something like Oracle that uppercases it. So if you don't put the double quotes around the object name that is not in all uppercases, then you will not find that object to be queried. And finally, your objects typically appear inside of a database or a schema or some other logical structure. And when you reference that object, you must include both the schema name and the object name with a period between them. DB2 and SQL Server sometimes have 3 levels of logic. So you actually have a database name, period, schema name, period, object name. So again, reference your RDBMS, but for MySQL, it has both a database or schema name, a period, and then the object name. Showing what this looks like, we will first bring up my MySQL workbench. And in here, as you can see, I have Daisy Hill as my database name, and I have some tables. Now, because my default database, when I define this connection, is Daisy Hill, I can just simply say select star. I'll make this bigger too. Select star from DateDim. Having done that, it finds the information within DateDim. But if I was not in, or did not have the default as Daisy Hill, then I would say Daisy Hill. And you notice it auto-filled it in there just for a bit. We can go back here very briefly. And you can see it does an autofill. I can click on that, it fills it in for me. Put a period. And then here's my date dimension. Click on that as well, it fills it in. But if I actually put date dimension as DIM, well, let's do the positive result first. Using the proper case, you see that it executes it and returns the data. But if I don't use the proper case and execute it, you see down here an error code that it did not find it. So you need to make sure that you have the proper cases. Autofill, drag and drop are all great ways to do this. You also then would want to reference your objects within Alteryx. So for here, in this input data, if I click on my SQL database that I have, it will pop me up. I usually use the SQL editor, and I can just type in the name of the object. I can test the query, it'll find it. I also have the ability to go into the tables list. Now, if you notice, there's no database or schema name in front of these objects, and these objects have a quote around them. This is something that I don't necessarily like, and I don't like much of the navigators in the Alteryx input data screen because it does not give me anything other than my default database. So any other object that I want to reference that's not in my default database, I have to know the database name and its object name. Also, if I click on this, date dimension here, click OK, you see that it went and put the date dimension in the actual backwards single quotes. This is fine. Alteryx understands how that works, but I tend to believe that it runs me into issues. I tend to click on none, but you see it didn't change this whole selection anyway. So it's interesting how this doesn't really slide and work within itself. So just be careful as you're selecting through this widget. And that is why when I come into these widgets, the input data one, I typically come into the SQL editor, and you notice there it actually put that name in single quotes, and I will just go ahead and put the name in there myself in the format that I like, which is without those backward quotes, and it goes ahead and finds it. So again, look it up, talk to people, and we'll talk about how to find some of this information out once I close out this little sample window. So how do you find that information? Well, in days gone past, you had to find a manual, buy a manual, see someone that had a manual, or be gifted with a manual. Now all these manuals are available online. If you Google something like Oracle Reference Manual, you'll see that it comes up. Click on these, it takes you into the online manual for Oracle. If you do the same for MySQL, you'll see that this website will come up, which I included here in plain text for you to see. And what that means is that click on that link, it brings you into the MySQL reference manual so that you can understand how it is working, go through and find information that you would need. It's a nice little search feature. I haven't extensively used this documentation because, as I've mentioned before, or will be mentioning through this class, is I tend to keep my SQL language interface to the RDBMS pretty vanilla, so that is the same across different versions. But this information is here. You can look it up. You can expand this out looking for functions and operators, which is a great place to come look for this information. How do you find objects that you might want to query? We talked about how within the MySQL Alteryx widget, it only shows you the current schema. How do I find other ones? Well, it also turns out that every RDBMS has a set of views or tables that have in it the names of tables and views, the columns and indexes associated with them as well. You just have to learn how to query through them to get all the information that you need. In some cases, it can be very extensive. For example, I have been in Teradata data warehouses that have had 4,000 or 5,000 tables in them. And so trying to weed your way through all of those objects to find the ones that you need can be a bit stressing, but at least the database itself can help you find what you're looking for with some queries, which again is a point to this class, is that how do you find that information? It's nice to be able to write a quick little query to do that with. But you also can do that with Alteryx once you know what information might be in these schemas. So anyway, so the schema for MySQL is called information schema. In Teradata is called DBC. In Oracle, they're owned by Sys, but there are synonyms available so that you don't actually have to know how to find the individual data dictionary views. You just reference them by their name and don't have to worry about what schema they are stored within. How can you find out the information of what's in these or how to locate them? Well, see the previous slide where we talked about finding your documentation online. Take a look at this pretty quickly. We can see that this is in Alteryx. We want to start out with MySQL Workbench. You can see that by default I have a little navigator over here on the left, but it only shows me the actual application schemas that are created over in here. As you can see, it has all the objects in Daisy Hill. I also have another application I'm working on that is TillFin, and so those objects are listed here. But that doesn't help me finding objects, especially since this information schema has information in it that we would like to use. But I do know from looking up in documentation that there is a tables view in information schema that will list all the tables out there. So if I execute that query, it returns me a list of the schema and all of the tables within those schemas, along with other information about those. Also, if you'd like to actually be able to explore out what's in the information schema without referencing the documentation, you can modify the parameters of the MySQL Workbench Navigator by going into Preferences, SQL Editor. By default, the Show Metadata in an Internal Schemas is turned off. Click that turned on. Come here to your refresh button right there. Click on the refresh button, and now you can see that information schema appears. We can expand out that tree. If that Navigator window takes a bit too long to flesh out for you, which mine did, I just went ahead and disconnected from my database, reconnected it. Did that without you having to watch me do that. But now you can see in here, we can look at the tables that are available for us to query from the information schema. So there is the tables that we used. Now we can also do that through Alteryx. So I created a quick little workflow that goes ahead and queries the information schema tables, select some columns that looked useful to me, sorted the data, looked at the sorted data, and also did a summarization so you can see what's inside of my database. So if you notice, here are all of the schemas and tables. Here's Daisy Hill. You also notice that you can go ahead and create comments for your tables and your columns as well to make your metadata a little bit more useful within the database. And I did that just for the date dimension so that you can see it's there. And then doing a quick summarization, you can see how many tables and objects are available within each of these schemas. So now you're ready to actually start creating your tables. You have your workflows. You're trying to determine what type of columns to create in the database to match up with your fields. And it's good to know that what types of data types within the columns are available on MySQL as well as on your RDBMS. Again, can't caution you enough. Take a look at the documentation that's online. If you look at the MySQL reference, right down here actually has data types, breaks them down by numeric, which etc. we're talking about. So for numeric data types, it shows you the integers, the fixed points, etc. that you have. Some other object types that I don't typically use and put on here, but the RDBMS breaks them down into at least these 4 categories, if not more: integer fields, fixed point fields, floating point fields, and bit value, which is a single 1 digit. Character columns, you have char, which are fixed length characters, varchar, which are variable length characters, and then typically some RDBMSs have what is a very large text string called text, which has predominantly, it says no limit to its length, but in most RDBMSs there is a limit to how large your text field can be, but you don't have to worry about choosing it. It's usually a pretty large number, like 4,000 or 8,000 characters. And then we have date time columns. MySQL supports a date only column, a column with date and time, the timestamp, which actually is a special data type, and it will do auto updating within your database if you properly set it up that way. You also have a time only, and For some reason, MySQL supports a year date type field. I'm not sure why you would use that, but it's available for you if you want to. More importantly, you have to understand how your data will be translated between MySQL and Alteryx. The bad news / good news is that Alteryx will do the conversion for you so that you don't have to worry about it. So you don't have to tell Alteryx how to convert each field to go into your RDBMS. The bad news is you can't control it either. Alteryx will make that conversion going to the RDMBS and a conversion coming from the RDMBS and make its best estimate for what to do. It's be very good for when you're creating your objects within Alteryx, that you understand what the data types that are being stored inside of MySQL once you create that data store by going into the MySQL database workbench tool and look at your navigator, so it'll tell you the actual data types for the columns that resulted from the fields that you sent it. And the same thing happens coming the other way, so it'd be a good idea to just go ahead and read all of your tables back in again and verify what Alteryx is doing with your different data types to give you a feel for what you need to do in the future for each individual workflow. I will mention this, which is why I talk about SQL language is important to learn, and that is that between Alteryx and MySQL, it has some issues with the date and the time fields. The way that you would correct the storage of that would be to manually create your tables within the MySQL tools. In that case, then Alteryx will simply migrate the data between the data type that it has and the data type that you have to properly get the data in there. So it's a good idea to test how all of this will work. But to show you what I mean about this little issue is that if you come down here, you'll see that I've created 2 work tables inside of my Daisy Hill database. And one is called date time data types. And you can see that I created, if I click on this right here, down here you see I created a column that is a date, column that is a date time, and a column that is a time only. And that data properly is represented in there and you can utilize it. So just to test how this works, I went ahead and did the same thing with an Alteryx workflow. Where I brought in this while we're talking about it, we don't actually need to run it, it's already been run. So I brought in the date time now. I created 3 fields, a date field, a date time field, and a time only field. Verified that those data types were proper, and then inserted that data into my Alteryx database. My MySQL database. I then took a look at what was created, and this was a bit scary when I saw it. And what you'll see is that for the date, it became a date time. I had noticed this earlier, was wondering what was happening, but ignored it. When writing this class, I figured I needed to address it. So you see that an Alteryx date goes into MySQL as a date time. Date time is good. Scary, the thing was that the Alteryx time field went into MySQL as a character 8. And again, this is Alteryx doing that conversion. The way you would fix this would be to create your own table and then insert the data into it. And then it would work properly. We'll talk about that option later on in this series of classes. So in this little presentation with examples, showed you how to connect to your RDBMS, where to find information to answer some basic questions, trying to understand how to name your objects, how to reference your objects, and how those object names will be stored. Take a look at your data types, take a look at how to quickly query into the data catalog to find objects, both within the native MySQL workbench as well as within an Alteryx workflow, and then discussed how Alteryx translates between data types for you automatically and what to look out for. Biggest caution is always test and look at what things are doing for Alteryx. Don't make assumptions. And work on your workflows from there. Hope this helped. Subscribe to my channel. Leave me some comments. Want some additional information? Please drop me a note.